Okay, can you hear me now? Yeah. Hello. Okay, thank you. So let me share my screen again. I hope now it's okay. Okay, so let me open my code editor. So it's open. So first of all, we will discuss about that. Suppose I want to filter the imagery for the dry season and also for suppose wet season. Okay. So these two season I want to monitor. Suppose water, and also for dry season I also want to monitor for water. Okay, and further I want to check how much water body increased in the wet season. Okay, how much water body increase in the wet season period. Okay, so there are a lot of things we can easily monitor using the water logging, and these things we also apply for the flood mapping. Okay, suppose before flood and after flood. So I'll just show you the practical example, then you can easily get the idea how we can easily work with this type of water logging using satellite imagery. So in this case, if you want, you can use here the Landsat, or if you want, you can also use here the Sentinel. So both are the same process. So in this case, I will try to show you for that Sentinel-2 satellite imagery. So basically, it is a more better resolution than Landsat. So then you also get the more better imagery when you are using the Sentinel-2 satellite imagery. So just let me open this Sentinel-2 multispectral instrument. So top of atmosphere is simply choose for that level 1C data, and this is the dataset information. Okay, and this is the availability time period, and this is dataset provided mainly European Union or ES Copernicus. So first of all, just simply just copy this ID and then paste here. Okay, and further just take a variable name. You can put any name as a variable. Suppose I put the name, just take a variable var keyword and put at the s2 equal these things. Okay, so this is my image collection. So this image collection I simply store it in a variable s2, and further just try to filter this image collection for two time period, mainly summer season and rainy season. We try to filter it. So before that, first of all, we are just simply filtering. Suppose we already know about that filter bounds. So this function help you where you need this image for your specific geometry. So now just simply import your geometry. Just click on the asset tab and then import your study area. Suppose I want to monitor the water logging area in Dhaka city boundary. Okay, or Dhaka city. So for the simply import your shape file. So just simply import. So it imported as a table. So you can put any name. I put the name suppose ROI. Okay, so just I put here that ROI filter bounds, and then I just simply use at the filter metadata. So this function we already know about that filter metadata. So basically it filtering your image properties. Okay, suppose in this case I want to choose suppose image properties, cloud pixel percentage, suppose less than 1. Just copy and then paste here, and further put here that less than, and set the value, suppose value for 1. So now what happened in this time, for this variable s2, this variable is stored only for those images which are available in my study area, and this image not more than 1% cloud cover. Okay, it indicating. So if I just use at the print function and apply the s2 and use at the size function, so now it computing how much images are available. We find out that 285. Okay, 285 image collection is available. In this case we are not filtering the when. Okay, we are not filtered this part for a filter date, because I want to filter the two time period, mainly dry season and wet season. So let's go try to do it. And in this case we are just using the filter metadata function. This function we already know, but instead of the filter metadata function, if you want, you can also use the another function. It's called the sort function. Okay, sort function, it's another function for filtering image properties or image metadata. So now what is the difference between the filter metadata and sort? So basically when you filter in a specific range, suppose I need less than 1%, less than 10%, less than 5%, or a specific number when you include, then we have to use the filter metadata function. But when you are not a specific number, suppose I need all of cloud pixel percentage, low cloud cover imagery I need without filtering a specific number, then we have to use the sort function. So in this case, if I just sort using these properties, just copy and paste here, and further I simply comment this line and run the code, you can say how much number you can find out. So now it also increase my image collection. Okay, so in this case I sort using this cloud pixel percentage. Okay, if you check the function from here, from the doc step, simply search here sort. So here you can see sort, it's the ascending or descending. So basically it show the ascending. Just click on here. Yeah, so click on here. So sort a collection by a specific property. So in this case I just use the sort function and I set the property cloud pixel percentage. Okay, so it's returned the sorted collection, and basically property mainly sort by cloud pixel. In this case we put in here, and ascending, so basically it's sort in the ascending or descending order. The default is true. Okay, ascending default is true, but in this case its default is the true. It means that when I use here the cloud pixel percentage, it including all of cloudy pixel image also including in here. But when I apply the false function, which is called default is the true, if I don't use anything then it work as a true. But when I apply the false function, that it easily remove all of cloud. So let's go, I will try to show the practically. So now suppose I want to, before adding the boolean operator, further I try to show you the image, and after you find out lot of cloud in your imagery. But when I apply the boolean operator just false, then it automatically remove all of cloudy pixel, and we find out the very neat and clean satellite imagery. So first of all we try to check it without boolean operator, what types of image we find out in here. So let's check. Suppose I take a variable dry image, and in the dry image I just call the s2 because it stored all of image collection. This s2 I want to filter date. I want to filter for suppose dry season perspective of Bangladesh. So just I put here suppose year of 2020 1st January from year of 2020 suppose 05/31. Okay, then I put here this type of things. Okay, and then after that we just try to create a, if you want you can also easily create the median. We already know about that median. We can easily create the median composite, or if you want you can put here the mosaic. Okay, mosaic, and further these things just simply clip with our study area, which is RY. So now let's check the image first. Suppose I want to add the layer, map dot add layer, and also call the dry image. Just copy and paste, and also focus the center. So just use add map dot center object is RY, it's my shape file. Zoom level suppose 8, and run the code. Okay, find out this type of imagery. So let me add the band combination. Suppose red, green, and blue. Stressing level suppose 98%, and apply. So now you can see find out there is a lot of cloud. Okay, you can see there is a lot of cloud. There is no image. We just find out only for the cloud because default it's a true. So but when I apply here, suppose just use at the operator false and run it again. So now in this time we find out the very neat and clean satellite imagery. Suppose I put at the red, green, and blue, stressing 98%, then apply. Okay, so now we find out the very neat and clean satellite imagery. But this imagery, basically bands value are not reprojected. Okay, that's why you find out this type of large number. So now how I can check the scale value? You can see here they already provide all of scale value for each band. Basically all of bands are the same, 0.001. It is a scale value. So basically when you calculate any kinds of index or work with this satellite imagery, then try to use this scale value for rescaling the pixel value, okay, or spectral value. So now in this case all of the same. So after mosaic I just simply multiply this value 0.001. This value simply copy, and then after mosaic just use here dot multiply with this value. Okay, just run it. So now it also rescaling, and we find out that proper or accurate pixel value or a spectral value appeared. Okay, now try to add the visualization. Suppose I put at that, suppose near infrared, then put at that red and blue. Stressing suppose 98%, and further apply. Okay, just make the band combination near infrared red and blue. Then import and then copy this visualization parameter, just copy and paste here. When I put it, it's a dry image. Okay, same things we also apply in here, just copy the same line of code and then paste here, and then give a variable name. So I change it, suppose it's a weight image, and put the weight season time period for Bangladesh, suppose it's a just 06 from October 31. Okay, then we also try to add this visualization, just copy and then call this weight image. Okay, and then okay, run the code. Okay, so now I find out the two imagery. If you check, first one is that, okay, also change the layer name. Suppose I put it say weight image. So you can see find out these two imagery. One image is for wet imagery, mainly rainy season imagery. Another is for dry season imagery, find out in here. Okay. So in the mainly rainy season, we find out some cloud, this type of cloud and cloud shadow. But this type of cloud we also remove. So further class I also already discuss about that, how we can easily remove the cloud and haze. Mainly basically this type of cloud shadow. You can see also find out the cloud shadow, this type of cloud and cloud shadow. So further also discuss about that. So now you can see this is the imagery. Basically it's the rainy season, so that's why you find out this type of cloud. And when you work with for dry season, you can see there is no cloud. We find out the very neat and clean satellite imagery. But if you check the difference between the two imagery, you can see the dry season imagery. So basically this type of black color, it's indicating about that water body. Okay, it's indicating about the water body. And if you check, you can see very less water body in the dry season. Okay, very less water body. But when I open the wet season or rainy season, we find out the lot of water body. Basically this type of place, you can see water body, also black or dark, this type of pixel indicating about the water body. But you can see there is no water body in the dry season. Okay, it's totally, you can see show as a vegetation. Also you can see it's a vegetation, there is no water body. But when I open the wet imagery, we can easily find out all of water body pixel as a black color or dark color in here. So I hope you can get the idea how we can easily filtering the image collection for two time period. Okay, mainly dry season and wet season. So now I hope network is well, and okay, and I also get the speed. I hope there is no issue now. Okay, can you hear me properly? Hello. Okay, thank you. Okay, so basically we are using the different types of composite. Okay, so we already use the one composite. It's called that median composite. If you simply search here median, uh, simply search here median. So median, it's one kind of reducer, or it also called that median composite. So this median composite reduce an image collection. Suppose if I just use the median, so that's what happened. It just reduce the image collection by calculating the median of all values at each pixel across the stack of all meshing bands and mesh by their name. Okay, so in this case when I apply the median, so basically it calculates the median value. But when I apply the mosaic, then what happened, you can see, just if you select that mosaic, it not calculate any kinds of median. Composite all the images in a collection using marks. Okay, so using the marks, it composite all the images in a collection. Okay, and we find out this type of things. So basically when you work with flood mapping or also water logging, so this type of things, then we try to use that the mosaic. Okay, basically in the mosaic it not create any kinds of median value or mean value. Okay, but when you apply the median, then it calculated the median values and create this composite. But in this case it composite all the images in a collection using marks and create this type of mosaic imagery. Okay, we find out this type of mosaic imagery. So this is the mosaic imagery for the dry season. You can see it's very very not much little pixel you find out for the water body. But in this rainy season you find out the lot of water body pixel. Basically this type of color, black color or dark color, indicating about the water body. Okay, and okay, another question is that, yeah, it also possible. Suppose for that we need to create that image collection, annual image collection. Suppose you just make the annual image collection for every 5 years interval, and further we can easily get it. So then we need to create this annual image collection, and I think I already discussed about that in the second base class, how we can easily create that annual image collection. Okay, suppose from 1992 2024 all of years. Okay, so annual image collection I already discussed about that. So these same things you can also apply in here, and further you can also create. So you also try, further face any problem, I also guide you how we can easily work with more better. Okay, so this is the way we just simply take the imagery for the different season. So now what I do for using these two satellite imagery, you can do a lot of things. Suppose I want to monitor vegetation, suppose I want to monitor water body, I want to monitor suppose vegetation change or water body change. So different type of things we can apply in here. Suppose in this case I want to check for water. Okay, so now how I can get the water from this satellite imagery? So we have these two satellite imagery. So when you extract the water body from satellite imagery, we are using the different types of index, water index. Simply if you search on the Google, suppose water index in remote sensing, simply search, then we find out the lot of resources about that, different types of. Suppose just simply open this. So here you can see different types of water index and their application. So basically we are water index as a monitoring tool. So we are using the different types of index, such as this is the one kind of index, it's called the normalized difference water index. So basically when you apply this index in your satellite imagery, we can easily extract the water body. Okay, we can easily find out the water body from our satellite imagery. And what is the formula about that? This is the formula. Okay, near infrared minus short wave infrared 2, near infrared plus short wave 2. When you apply this formula, then we can easily create the NDWI, mainly normalized difference water index, and from the NDWI we can easily extract the water body. Only water body can easily extract from here. Okay, you can see about that. Also value range, -1 to +1. Okay, also you can see this is the NDWI. Also you can see this is the another one, WRI, mainly water ratio index. So what is the formula about that? This is the formula about that water ratio index. So we can simply apply this formula and we can easily calculate the water ratio index. So it's another kinds of water index for monitoring the water on the from the satellite imagery. So you can see that also provide the range 0 to 1, mainly no water on the surface, 1 to 2.5 plants are counting moisture, 2.5 to 3.8 water bodies. Okay, they are also make this type of things. Also you can see MNDWI. So this is the another water index, mainly modified normalized difference water index, and this is the formula about that, green minus short wave infrared 2 divided by green plus short wave infrared 2. Then we can easily find out that. You can see value range from -1 to +1, and water has greater than 0. Okay, so when I apply this MNDWI, if I just take only all of those pixel greater than 0, all of pixel give me the water body, only water body it provide me. Okay, as well as if you suppose other, you can see NDSI, sono index. So let's go, we try to discuss one. You can also apply the same process for any others. Suppose I want to apply this formula, and from this formula I want to extract the water body from here, from the satellite imagery. So just I copy this formula, and further I want to add in my code. So this is the formula. This formula is that MNWI, green minus short wave infrared 2 divided by green plus short wave infrared 2. So if I just calculate this formula in my for the two satellite imagery, suppose dry and wet, then I can easily find out that dry season water body and wet season water body I can easily find out. So let's go try to apply it and then check what happened. So how I can calculate this type of formula? There are a lot of process for calculating this type of things, and today's session I also try to explore all of method how we can easily calculate this type of index or this type of formula. And after completing this class, you are able to do any types of equation you can easily calculate. Okay, not only for that, any big equation or a small equation you can easily calculate in Google Earth Engine. So let's go how we can easily calculate the modified normalized difference water index, and further from here how we can easily take this water body. So for that, just take a variable. Suppose I put the variable name is that NDWI. Suppose dry, I want to check for dry, just equal. So now this formula I want to apply. So using this formula we are apply the different types of method, but one method is very easiest method. So if I just simply search here this formula, it's called that normalized difference. So this is the function, and you can see e.image. So it show that it only work for the image. This function, normalized difference function, is only work for image, and this function you cannot work with image collection. Okay, so now I already create the image. I already create the two images, dry season image and wet season image. So I can easily apply this formula. Mainly I can easily apply this function in my image, and then further I can get the result from here. So now we check the description about this function. If I just click on here, you can see. So normalized difference, so argument mainly band name. We need to mention here the band's name, and it compute the normalized difference between two band. Suppose I have equation, and this equation have only two band, and if the bands to use are not specified, use the first two band. So the first two band, basically normalized difference is computed as first band minus second band divided by first band plus second band. Okay, so if I just use this function and mention here the first band and second band, then it automatically computed first band minus second band divided by first band plus second band. So let's go try to apply this formula. So just I copy this formula, and these things I want to apply. So I want to apply it for the dry season image. Okay, for the dry season image I want to apply it. So just call the dry image. Dry image, we already make the image, dry image. Okay, this variable is stored the dry image. You can see this variable is stored the dry image, and this variable is stored the wet season image. And now I want to apply the normalized difference function in my dry season image. So just call the dry image and then apply this function normalized difference. Okay, I want to calculate the normalized difference between green band and short wave infrared 2 band. So now I simply mention here the 2 band name. So first band, I put the first band, mainly it's a B3 green band, and short wave infrared 2 band, basically it's a B12. So if you check the band name from here, you can see. So green band, basically B3, and short wave infrared 2 band, it's the B12. So just I mention here the band name B3 and B12. So now it's calculated the NDWI, mainly normalized difference water index. It create the map. So let's check the map. So just try to add here, and if you check, suppose if I just use at the print function and call this NDWI dry, then we can get about this all of information about this object. So you can see it's the image. Okay, basically it's the image, and if you check it, you can see the bands, it show the ND. Okay, in default name ND, but I want to rename it. Suppose I put the name as a NDWI. So just I put here the rename function, rename, and if I just put the new name NDWI and run the code, so now it display the result as a NDWI because I rename it. You can see I put the NDWI. Okay, and you can see it's the floating number belongs with -1 to +1. This is the range of NDWI. Okay, so now it's an image. You can see we find out the image. So this image I want to display on my map. So for that we already know about that. Just use the function map dot add layer and apply the NDWI dry. I call it this function variable name dry and run the code. So now it create this another layer which that stored that in mainly MNDWI map. Okay, so we find out this type of map, and this map we find out, if you want you can also add the color. Okay, so let's go try to add the color. So for adding the color, just click on here, and if you check it through the NDWI, just I stressing it suppose 98% for better visualization for my map, and put here suppose low pixel. And if you check the range about that, so this range basically -1 to +1, and water has values greater than 0. So greater than 0, all of values indicating about the water body, or positive value indicating about the water body. So let's go try to add the color. Suppose negative value I want to show it's not water, it show this type of red color. Greater than, I put here this type of yellow. suppose greater than, I put here this type of green, and water body show as a suppose blue color, I put it. You can put any color combination and further apply. So now this color is added on our map, and if I just import it and further just copy this variable name, just copy and paste after, and then just put the layer name, it's a suppose NDWI. You can put any name as a layer name. So now you can easily find out, you can see this type of blue color indicating about the water body. Okay, and this is the MNDWI for the dry season, you find out. Okay, it's the dry season MNDWI. If you check the value from here, suppose just click on the inspector tab and click on the water body, just click on here, we can find out the positive value for the water body. It show the positive value 0.6 positive value. But suppose if I just click on this type of vegetation or others, so now it show about that this type of value, you can say very less 0.2. okay, suppose if I put this type of things barrel land, so it show the negative value. Okay, this type of things, but water body we find out that positive value. So now the same things I also want to apply for another one. Suppose if I just take a variable suppose NDWI for suppose weight, okay, put any name. So now just call the weight image, because I want to calculate for NDWI for wet season, rainy season, and further this same code simply copy, just copy and paste here. Okay, and further I want to add the layer, so just put here, just copy the same code again for that map.add layer, and then call this NDWI weight, just copy and paste. So now run the code. I also put the name, it's the NDWI for dry, and this one is for wet. Okay, just put the layer name. Okay, so you can see, find out this type of blue color indicating about that rainy season water body. You can find out this type of place, but you can see there is no water body in the dry season. Dry season show the only for this type of things, and in the rainy season you find out that this type of water body. Okay, if you check, suppose I click on here, just click. So now let's check the value from the inspector tab. So here you can see, find out that in the dry season we find out the very low value, but wet season or rainy season find the high positive value. Okay, suppose if I just click for this coordinate, you can see, find out the very low value, but dry season we find, rainy season we find out the very high value. Okay, in the dry season very low value we find out in here. Okay, so now further, suppose I want to extract the water body. So now you can see this satellite image show about the only other feature also in here, but I want to just need only for the water in the dry, only for the water for wet. Okay, other features I don't need. So now we apply a threshold value. Suppose in this case I just take a value, take a variable, I put the variable name, suppose dry water. So now just call the NDWI dry. So from here I can easily extract the only for the water pixel. So for the just put here the greater than 0. Okay, greater than 0 all of pixel I consider as a water body in the dry season. So now further if I just add here map dot add layer and call the dry water. So now it show only for the water. So when you apply this type of things, it provide you the binary class. So basically water and non-water. So for that just we make a dictionary. Suppose mean 0 and max 1, water and non-water, and also put the plated. Suppose I put the plated is that no water show as a gray color and water show as a blue color. Okay, I put the binary class. Suppose when I apply this type of things, basically it added the binary class, it stored the binary class. One is that all of pixel greater than 0, another is that all of pixel less than 0, we find out from here. So now I just put here all of greater than 0 I consider as a water body. So I want to display it as a blue, and where there is no water it shows as a gray. Okay, you can put any color. And further I put it's a dry water. You can put any name as a layer, just run the code. Okay, we can see in this case we also face this type of map, but this map is not accurate because in this case it basically this is my NWI dry season map. If you check it, so I find out only for this place is the water, but it show all of place. You can see that the lot of place we find out the water. So in this case if I use here the greater than 0, if I just use here the greater than 0, then it don't show me the proper result. So this is the problem. So for what is the solution about that, how I can find out that best value? Okay, suppose which value easily differentiate the water body. Okay, suppose in this case randomly, further I will show you the process. Suppose randomly I take the value 0.0 2. Okay, I consider all of 0, okay, 0.5 or 0.2 I consider. Then let's check what happened. But it has a actual value. Okay, so when I use this value I can easily differentiate water and non-water, and in this case we are apply the different types of method. So now I can say I think also it reduce some water pixel. Suppose if I just put here the greater than suppose 3. Now let's check what happened. So now if you check it, I think now it will look more better if I just put the 0.3. So now we can easily get only separate only for the water and non-water for this area, and this value is not fixed. Okay, so every study area it will be changed. Basically it's different on the reflectance value or bands value also defines this type of threshold value. So that's why we also learn about that how we can easily apply the outshoe. Okay, so basically outshoe is one kind of method. Basically it's perform automatic image thresholding, and when I use this thresholding I can easily separate the water body or anything, we can easily separate from here. So if I put this I can get this type of result. Suppose if I just put here the 0. Suppose 0.4. So now it show me the all of pixel greater than 0.4 and create this water body map. So now it create this type of things. So now I can say I think this map is also okay. If you check the compare the result with this layer, basically compare the result with the NDWI dry season layer. If you check it, this is the map, and this type of blue color we find out the water body. And when I struck the water body using thresholding, I can find out only for this place water. You can see okay. So it not mixing. But previous time, if I just get the value greater than 0, then it creates some problem. Okay, so from here it's a one way, randomly we take the value and we can easily take the decision. Suppose for this time, for this MNDWI from this map, if I just take all of pixel greater than 0.4, then I can easily separate only for water body. I can easily separate the water body. You can see all of water pixel show as a blue color. And it also, you can see, if you compare this result with your MNDWI dry season layer, we find out the accurate result. You can see. But now how I can calculate this type of value? Okay, suppose if you do randomly, sometimes you face some problem. Okay, so that's why it's better to use. Suppose how I can confirm, how I can get the value. So you can see, if I just put here the 0, it show the all of pixel show as a water body. You can see again, you can see it show the lot of water body, but there was no water, but it show the water body. Like if you compare this value, you can see this type of blue color indicating about the water body, but this type of place there is no water. And if you compare this result with this layer, then you can get the lot of different. Like you can see this place there is no water, this place there is no water, but in when I apply the greater than 0, it show me there's a lot of water and it destroy my result. So that's why it's very important to find out that best value. So in this case, randomly I check, I find out the value is that 0.4. Let me write in here. Suppose if I just put the greater than 0.4, then I can easily differentiate the water body in the dry season and non-water body in dry season. So now how I can get this type of value? Okay, so for that, okay, I will back again. So let me show you the practical example about that, then we back again in here. Okay, so in this case, suppose I want to find out the OTSHU. So basically OTSHU is one kind of threshold value, find out the best threshold value, which value help you to segment. Suppose I want to work for water and non-water. Suppose I make the NDWI, and from the NDWI we already know about that all of pixel greater than 0, then we can find out the water. But which value is better for my study area, I don't know, and this value is not fixed. Okay, suppose in this case I want to create the NDWI map, or I want to create the, suppose anything. Okay, suppose for flood map, suppose I have a water, I have a water body, flood water and permanent water. So how I can differentiate? Okay, so for differentiate help you mainly OTSHU. So let's go try to show the practical example, and this method is also apply for flood mapping. Suppose I just calculate before flood and after flood imagery. Further, from the before flood and after flood, we just calculate which value provide me the best separation between the flood and permanent water, flood water and permanent water. So these same things we also apply in here to find out the best number of value which will help me to separate. So let's go try to discuss about that how we can easily apply this method. Suppose in this case I want to apply the same. Okay, just I copy and paste in here, it also easy. Suppose just I copy the image collection, I use the same imagery, just copy and paste. Oh, sorry. And then I remove all of those. Okay, just I apply for only for the single image. And I also put here, suppose, filter date year of 2020, 1st January. Suppose I take 1 year image, 2020 December 31, I put in here. Okay, 1 year. So now I want to create a function. Suppose this is my image collection. If you check how much image is available, if you just simply use the print function and check it the S2 and use the size function, now we can easily find out that how much image or ROI is not defined. So just we simply import our study area. Where is it? Okay, I import the Dhaka city boundary and I put it say ROI. So now let's check how much image. We find out the 146 image collection is available. And if you check all of images, just check the all of image collection information. So then we can easily just print it. So now it visualize about that all of image collection information. If you check all of images mainly featured, and all of images stored the band, mainly 19 bands is available, you can see. Okay, but in this case I want to create a band. Suppose I want to create a band of NDWI, and this band I want to connect with all of images, mainly 146 images. Okay, so now I want to create a band, and this band I want to connect all of images. Basically in this time 146 image collection I have. So I want to create a band, and this band I want to connect all of image, total 146. So I can also do it randomly, one by one, but it takes a lot of time. So that's why in this case we are also help of function. Suppose I create a function. This function help me to connecting the band of NDWI with all of images, 146, all of images. It automatically connecting. So let's go try to discuss about that, how we can easily connect a band, okay, with our image collection. So this is my image collection. It's total 146, and every image collection, if you check the band, so you can see all of image collection. Just click on, you can see the bands. So it show only for this type of band, which bands are available in the satellite imagery. But I want to add a new band. Suppose I want to add NDWI band for all of images. Okay, so for that we need to help concept of function. Okay, so if I create a function, this function easily help me to connect all the band of NDWI with all of images. So let's go, we just create a function. So how we can easily create a function? So for that we already know about that. Just I create a, suppose I just create in here, suppose create a function keyword, and put the element name. You can put any name as element, suppose img, and then just use the curly bracket. In this curly bracket I put my argument. What is my argument? My argument is that I want to use this img, basically one element, one image I want to use, and then I want to calculate the NDWI or any other band. In this case NDWI I want to calculate, and further this image I want to work as a bands. Okay, so further when I check, I can easily find out it show the bands of NDWI in here. So let's go try to make a function. So my first argument is that need to calculate the NDWI. So let's go try to calculate the NDWI. Just take a variable. Suppose I put the variable name is that NDWI, and I just call the image. So basically this is my element img, and apply here normalized difference. Okay, normalized difference between two band. Suppose for NDWI formula is that green minus near infrared divided by green plus near infrared. So just I call the green B3 and near infrared basically B8. So this is the formula about the NDWI. So you simply put at the B3 and B8. So it this function basically automatically calculated B3 minus B8 divided by B3 plus B8 and computed the NDWI. So it's my first argument, and second argument is that these things I want to use as a band. I want to use it as a band. So how I can convert the band? So for that, just use here the return this element add bands and call this variable name NDWI. Just copy and paste here. Okay, so now this is a function. This function help me to calculate NDWI as well as also work as a band of NDWI. So this is a function, and I have a already total 146 image collection. So now it's stored in here. Okay, it's stored total 146 image collection, and this is my function. So for connecting, we already know about that. Just use here the map function, put the parenthesis, just remove and then close it in here. So now it's successfully connecting. And if I just run the code and then check what happened, just run the code. So now all of images added a new band, and this new band called as the ND. If you check it from the feature, any image, you can see all of images, just you can find out the 20 bands. It show the ND. So default name as a ND, we already know about that. So just I want to rename it. So for the rename, just use here the dot rename and put here the NDWI as just run the code. So now you can easily find out if you check the band name from feature, and now check bands, if you check it also at the NDWI. So it's very important when you work with time series chart, you need to connecting the band with your image collection. Okay, and this is the process. When any band we can easily connect with our image collection. So in this case, first of all, I have total 146 image collection. Okay, and then all of images I want to connect this band which I calculate in here. So in this case, NDWI we can connect, and it's very helpful when you want to create any time series chart. Okay, suppose I have to make the time series chart for NDWI, NDVI, or any indices. When you calculate the time series chart, so this band of NDWI, EVI, SAVI, these things we need to connect with our image collection. Okay, then apply the same process, it will be connecting. So we can easily find out all of image collection, total 146 image collection is successfully connect with all of band, mainly NDWI band is connecting. Okay, so this is the way we can connect, but in this case our main focus to calculate the threshold value for NDWI. Okay, so after calculating this collection, we have to just need a open Earth Engine library. Okay, so open Earth Engine library, what is that? If I simply search here open Earth Engine library, simply search. So here you can see, find out this type of link. It's the open Earth Engine library. So just let me open it. So here you can see this is the one kind of function. To use library, simply do the following: import in your code, use the function. So you can see simplify load, so we can easily load this type of file. So it's one kind of open Earth Engine library. So this type of things we can use, and further we can easily work with that. Okay, basically for the different purpose, this type of library help you, and these things we can also connecting with Python also. So here you can see it's one kind of function we find out in here. First function, so this is the editor, basically this is the snippet ID or function. I simply copy. So this is the open Earth Engine library. So user open it and a library load all. So it means that if I just use it, so it add all of library, it's load all of library. Okay, so different types of library, suppose OTSU threshold value. So in this case we are just focus OTSU threshold value, just a copy and further I just paste here. Okay, so now you can say I simply import my library. So this is the open Earth Engine library. So it not connecting from the docs tab. Okay, docs tab basically it already create all of function and stored in here, but in this time we are just use here the open Earth Engine library. So this library including lot of function, so it outside of Google Earth Engine server. So that's why sometime it takes some time, because it's not on the server function, it's connecting from the others open Earth Engine library. So we try to use it, and further we calculate for threshold value for NDWI. Okay, so let's go try to check it. So just import, and then I take a variable, suppose shoe. You can put any name as a variable, and in this function I just call it and paste here. And now just I apply here image collection. Okay, image collection, and then apply this function called that shoe threshold. Okay, so just I apply the same thing. You also need to write in here shoe threshold. Okay, I want to check it for also threshold, and these things I want to check it from my, in this case basically S2. It is stored all of imagery. Just I paste here, and then which band I want to use in here. I want to use for NDWI. I want to check for NDWI threshold value. If you check for NDWI, okay, just I put it the NDWI. Okay, so now this value I want to check. So for that, if I just print, suppose print this variable and run the code. So now in this time Google Earth Engine work little bit slow, because in this case we are just call the Open Earth Engine library. Okay, just I run it again. Yeah, so it's working. Okay, so we find out one band and threshold. We find out the float. Okay, we try to add it as a chart, then check what happened. Just a minute. So from the chart we can easily get it the better result. Just take a variable, suppose chart, and I want to chart, basically create a histogram. So UI dot chart dot image dot histogram, and we calculate the histogram for this also. Just copy and paste here, and then define the study area, which is RY. Scale I put here suppose 10, and now let's check. Okay, we also need to print the chart. Just print the chart, run.
Excuse me.
Yes,
Hello.
yes, please.
Yeah, can you repeat this code again?
Okay, I'll repeat just a minute. Okay, so in this case our main argument is that we try to find out that best value. Okay, so his value provide me the accurate separation. Suppose if you check, we just, when I apply here 0.4, then we can easily differentiate the water body. If I just put here the 0, then it gets some problem. Okay, so this type of value is different for the different region due to the reflectance value, okay, or bands value. So now we need to find out which value is give me the best result, mainly best separate, suppose water body and non-water body. So these things we can connect from outshoe. Okay, in Google Earth Engine platform we can easily use this type of Open Earth Engine library. Okay, this Open Earth Engine library has already available in our Open Earth Engine library. So from here we are just call this function. Okay, because this function is not available in our docs tab. Okay, so further we simply call, and then we are just call, it's stored in this variable. So just I call it and put here this variable name and image collection and put the Otshu threshold. So this is the things we have to use it. So it's one kind of function. Suppose from this variable it is stored this function. So from this function we just call this from this library. Sorry, it's a library. From this library we are just call this function Otshu threshold. I want to check it for my image collection. I already calculate the S2, which is including NDWI. Already make the NDWI, it connecting with all of images. So now further from here we are just check the threshold value. Okay, so basically which value give me the water pixel. So we can easily find out from here which value give me the water pixel. Okay, when it's generating the chart. Okay, actually which value is the better, we can easily find out from here.
Okay, okay. That means instead of guessing 0.2, zero
Yeah,
point
yeah,
0.5,
yeah.
we can use this. Okay,
Yes, yes,
thank you.
yes, yes. So these things we also apply for the flood mapping, for the separation of the flood water and permanent water, or any value. When you just use the threshold, just apply this type of thing, then we can find out the accurate value. And when I use the value, then I can easily find out that water body easily we can find out. Otherwise some pixel also mix in the water. Okay, it takes some time. Okay, let me increase the scale value, then let's check what happened. So basically, okay, now let's check. And this is the open earth engine library, so that's why it's not connecting from the docs tab. Okay, that's why it for this it takes some time. Okay, so in the meantime, let's discuss about the another things. So it also running, no problem. We check the later after some time. Okay, so we find out suppose 0.4 is perfect for this water body, and further the same things I want to apply. Suppose for this wet season. So for that, just take a variable. Suppose wet water and call this NDWI wet. So in this case, these things we also need to check which value is better to extract the water body from rainy season. So I just randomly put here greater than suppose 0.4, and these things I want to display and then check. So we'll just copy the same line of code. Just copy and paste here, and I put it's a layer name, suppose wet water, and then call it this variable name wet water. Just copy and paste here, just on the code. So now let's check what happened for this layer. Now we find out this type of things. When I apply the 0.4, then you can find out this type of place is the water, and these things come from this NDWI wet season imagery. Okay, you can also compare randomly from here. Okay, there is not much difference, you can see, we find out. Okay, okay, so now we get this type of things from here. And if you, okay, so in this case we make the binary class, basically water and non-water, for the different two season. But I want to create only for the one class. Suppose this type of gray color is not need. Okay, suppose this type of gray color I don't need, so I create the binary class. Sorry, single class. So in this case it show the binary class, but I don't need for suppose this type of gray color. So how I can remove it? So when you remove the binary class and make a single class, so then we have to use a function. This function called the self max function. Okay, so for that just use here the dot self max, and also put here the dot self max. Okay, and now when I apply the self max function, so now it convert as a single class. So for the single class, don't need to put this type of things, just I remove. Just I mention the color, suppose single color I want to display for this water body as a blue color, just remove it. And also for remove from here, and also color. If you want, you also try to display the color for different two colors. Suppose I put at that red color. So red color indicating about the wet season water, and blue color indicating about the dry season water. So let's go try to put in, just run the code. So now when I apply the self max function, then it creates the single class.
सो गया क्या कमर एक्चुअली इधर सर करके सोते थे
So here you can see, find out this type of things. In this case, there is no.
जब बेडरूम में सो
So it's also more better. Suppose if I just try to add the layer first, suppose this layer I want to put this before the
वो
dry,
बंद कर
just paste here, and then you also get the more better visualization.
होमवर्क वगैरह हो गया कल तुम्हारा क्लास है
Okay, kindly mute.
मैसेज डालो ना राशि को पूछ लेना अभी 10 मिनट
Okay, yes. So here again, so we find out this type of result. Okay, so here again, so we find out this type of map. Okay, so from this map we can easily get the idea. This type of red color indicating about that water body in rainy season. Okay, rainy season, and this type of blue color indicating about the water body in dry season. Okay, you can see now we can get the differentiate between that dry and rainy season. Okay, rainy season, this type of, we can find out a lot of water body in the rainy season. Okay, and dry season only for this type of blue color we find out in here. Okay, you can see there is no water body in the dry season, but rainy season we find out the water body, this type of places we find out in here. Okay, but now,
Excuse me.
yeah, please.
Can you make a difference map, like
Yes,
different?
Yeah, we also discuss about that, and also calculated. Suppose how much area we find out, that we also discuss about that. No problem.
Okay.
We also discuss. Okay, so I hope we can get the idea how we can easily apply the self marks and find out the single class of map. Just remove the binary class. But when you need the binary class, suppose water body, non-water body, then we just put here that color min max 0 and 1 and also work with that. So now if you check it, we find out this type of threshold, histogram threshold value for different frequency histogram. So if I just open it, so from here, if you check it, the value, so here you can see negative value. Also you can see negative, basically this type of negative value, it's indicating about that non-water. Okay, this type of negative value, this type of result, you can see it's indicating about that there is no water. Okay, there is no water, it indicating about that. So if you check it for the value, you can see it's the negative 0.008, it's not water. If you check it negative 0.0, it's not a water. If you check it from here, you can see the 0. Okay, we find out that if you check it, this value 0.004. Okay, also you can see the value 0.008. So if I put here this value, so this is the pixel of water we find out. You can see 0.023, 0.27, 0.031, 0.0. So it show me the all of value. Okay, from here we can easily find out. So you can see the 0, negative 0.008, it's not water. Also you can see 0. Okay, this is the 0. Okay, this is the 0 we find out. So from here, greater than 0, all of those are water. Okay, from here all of those pixel indicating about that water. Okay, and from here all of those are non-water we find out in here. Okay, so in this case we find out this value. If I just put here the 0, and you can see the 0.004, Suppose I take the value greater than 0.004, then it easily differentiate the water and non-water. Suppose I take only for those value, then we can easily differentiate water and non-water from here. But if I take this type of value, then it create this problem. Some pixel is also mixed. So in this case, if you from this histogram, if I take suppose this value greater than 0, or if I put at the suppose 0.00.004, then we also find out suppose greater than all of pixel 0.004, then we can easily find out that proper separation between the water body and non-water body. Okay, so in this case, if I just put at the 0.004, then we also find out that more better result for this case, for this time, basically for this whole time period we take the imagery for this study area, then we can easily differentiate. So this same concept we are also applying for our map, and further we can easily get this result. Suppose these things I want to apply in here and then check what happened. So in this case, for that we can simply, you can see here, so basically open it Earth Engine library. These things we can apply in a image collection. Okay, suppose in this case we consider all of image collection, but here you can see here I already make the image of NDWI. We already make the image. Okay, so let's go try to check the value using the histogram. We try to make a histogram and then check. Okay, so for doing these things, okay, I write the put in here. Just take a variable. Suppose I put the variable in a chart. I want to create a histogram chart. So put here UI dot chart dot image dot histogram, and I want to make the histogram for NWI dry season and rainy season. So suppose I call this NWI wet season water, or NWI dry, NWI wet. Just I copy and paste here, and further define the ROI, put the scale value for 10. Okay, we just print it, the chart, and I take the another variable, suppose chart 1, and then put here the UI dot chart dot image dot histogram, and I calculate for that dry NWI. Just I copy and paste here, and then put here that ROI zoom scale suppose 10, and also print the chart 1, chart 1. So now run the code. So now I create this two histogram chart. Okay, we find out this is the NWI histogram. So first chart for wet season, and this is the last one is for dry season. Okay, so now we try to check for the value from here. Okay, just I click on here. So if you check 0.1, 0.3, so negative 0, 0.016. So I think this value start from here 0.016. Okay, we find out that 0.016. Okay, 0, then this column, yeah, 0.016. So greater than all of value 0.016 for this code, greater than 0.016, all of those consider as a water body. Okay, for this graph, mainly this is the NWI wet season. Okay, for the wet season we find out the value. If you check it, we find out this 0.016. Okay,
Bhaiya,
yeah, please.
I don't understand this histogram. I mean, what is it? uh, I mean, what information it is providing
Okay,
actually?
okay, understand. Yeah, so basically if you check it, this type of x column, it's x column and it's y column, so it's called the frequency. Suppose if you check this type of value 0.00781, so how much time I find out this value, how much, you can see it show the counting number 45,666, so it's counting number total this value. Okay, so in this it's one kind of value, suppose NWI pixel value. Okay, this type of pixel value, and this frequency show that how much time I find out this pixel value. Suppose for this you can see we find out that this value 0.023, how much time we find out it. If you check it 0.008, how much time we find out in here. If you check it negative 0.08008, how much time we find out this value. So this is one kind of histogram. So basically it's called the frequency histogram. From this frequency histogram we can find out any pixel, how much time we count, how much time we find out for this pixel. This information you can count, and in this case if you check, we can also find out that what is the maximum value. Okay, you can see 0.09. Okay, it show the 0.09, it show the highest value, mainly it's the highest value of NDWI result for my study area. And how much time we find out it, 692 times it count 0.9. Okay, and this is the highest value of NDWI in the rainy season for my study area. But if you check it for that dry season, if we try to check it for dry season, what is the highest value. So for the dry season I think, yeah, you can see 0.6. Okay, 0.6, or we consider this column, or 0.6. Okay, we find out the 0.6. So 0.6 is the highest number of NWI pixel in the dry season. But for the rainy season we find out that, you can see what is the value. This highest value is that 0.9. Okay, we find out the 0.9, it's a highest value for this rainy season. But for the dry season we find out that, for the dry season we find out the 0.6. Okay, so now using this information we set a equation. Okay, suppose I will show you the equation, then I also describe it again. So this type of things basically provide you the threshold value. Suppose in this case if I just write this equation based on my value, suppose NDWI weight, suppose greater than 0.6. Okay, and NDWI suppose dry less than 0.6. So using this equation, suppose in this case I find out, you can see I find out that 0.6 is the highest number for the dry season. So all of greater than including the rainy season water in this time for this graph. Suppose if I just compare only for this two graph, so between these two graph we find out that 0.6 is the highest for the dry season. But we find out that, you can see 0.9, it's the highest level. So you can see it also available for the 0.6. So this type of things, from this column to last column, this type of water body we find out in the rainy season. Okay, from suppose you can see 0.6. Okay, 0.6. So this is the lowest level, sorry, this is the highest level of dry season water, okay, 0.6, and this is the lowest highest level of rainy season. Between this pixel, it's indicating about that rainy season water, okay, because you can see two graph from this two graph. So this graph for the dry season, we find out that in the dry pixel, so all of pixel greater than 0.6, all of pixel indicating about that rainy season water, okay. And another part you can see, and NWI dry less than 0.6 indicating about the water body. So if you check it, NWI dry, so less than this type of value indicating about the water body. So in this case, if I just use this formula, then it provide me the rainy season water, only rainy season water we find out. And we can easily find out this type of place, we find out the rainy season water, this type of place find out the rainy season water, and further from here we calculate the area. This same concept also used for flood mapping. Suppose if you show the another example for the flood mapping, then it will be more clear. Suppose let me show you my previous code. Just try to open it. Okay, so let me show you this. Just run the code. Okay. Okay. In this case, we try to create the two images. Suppose for the flood, after flood and before flood, we create it. So further from the before flood and after flood, suppose this is the dry season, this is the wet season. Okay, same process, dry season and wet season. And further from here we try to calculate the flood inundation, basically flooded area, as well also permanent water area. Okay, so this type of blue color indicating about the permanent water body, but this type of things is that indicating about that flood inundation area. So now how I can do it? So just I show you this part, then I'll try to explain this code. So in this case, for the flood, so for this study area, we find out that before filtered greater than -2 and after filtered less than -2. Okay, from my thresholding, suppose just I simply compare these two chart maximum value for the dry season and wet season. So from this value, we just find out this -20. Okay, so before filtered greater than -20 and after filtered less than -20. If I just put, then we can easily find out the flood water, or flood water we can easily find out this type of red color we can easily find out in here. So this same concept we also gain from here. So in this case, if I just simply check this two chart, so in this case for that we find out the 0.9. So this is that highest we find out for that wet. Okay, and for the dry we find out that 0.6. Okay, so basically we find out the 0.6 and these things were that 0.9. So now if I just take the NDWI weight, suppose from the NDWI weight we take all of pixel greater than 0.6, it's indicating about that water body, and less than 0.6 it indicating about that rainy season water body. So if I just in this, for this case, I just try to find out the threshold value and I find out the 0.6. Okay, now if I just use it, then I can easily find out the rainy season water, only rainy season water we find out in here. and also calculate that how much area. We also calculate this type of things from here. Okay, so any question you can ask me, or any confusion about that also ask me, please. Okay, so try to apply this formula, and this value is not fixed for any other study area. Suppose when you apply this code for your own study area, must be checked basically 2 time periods. Suppose in this case rainy season and summer season or wet season, or when you work for the flood, before flood, after flood. So this type of things you must be checked, otherwise it show the different result. So for my study area, I find out the 0.6. We find out the 0.6 threshold value. If I just use a 0.6, then I can easily find out that rainy season water. Okay, I'll also share all of code, no problem. All of details I will share. You can easily get this, no problem. So now we try to apply this formula. So let me add just take a variable. Suppose I put the variable name is that rainy water. You can put any name and then equal sign. So now I just call this NDWI wet. So this is the NDWI wet. Just I call it and paste NDWI wet. Greater than, I put the value greater than 0.6 and NDWI dry, basically NDWI dry. Just I copy and paste here and set less than LT less than 0.6. So now if this two condition is true, then it indicating about the rainy season water body. So not only for the one. So basically AND gate, OR gate, NOR gate. So this type of gate. So for the AND, if the two condition is right, suppose I find out a pixel greater than 0.6 from NDWI wet and less than 0.6 from the dry NDWI. So then it considers a rainy season water or rainy water. Okay, because in this case we apply the AND. So for the AND, both of condition must be true, then it will be true. Okay, so AND gate. Okay, so now we try to add the layer. Suppose I create that self marks. I want to create the single layer, or if you want, you can also create the binary. Also, there is no problem. So we try to add, suppose just add, suppose map dot add layer, and call this rainy water. So this type of water we find out. Suppose I put here suppose I put that plated. I put the color, suppose yellow. You can put any color. Okay, and run the code. So now it provide me yellow color. It indicating about that greater than 0.6 from NDWI wet season and less than 0.6 from NDWI dry season. Only show this type of pixel as a yellow color. Okay, I try to increase it. So here again we find out this type of yellow color. It's indicating about that water body. This type of water body we only find in rainy season. Okay, so this type of place there was no water in the dry season. Okay, there is no water in the dry season. And if you check the pixel value, suppose if I just random, I want to check for this place what is the pixel, I can get it. Just click on here. So now let's check this layer pixel. We can find out, we can check it. We find out the 0.8 which is greater than from 0.6, and we find out the 0.2 which is less than from 0.6. Okay, so now both our condition is true, so that's why it show the yellow color. So not only for that, any yellow pixel if you check, suppose just I click on here, so now we must get the result greater than 0.6 from NDWI wet and less than 0.6 from dry. So let's check again. So if you check the result, we find out the 0.7 which is greater than from 0.6 from NDWI wet and we find out the 0.2 which is greater than from NDWI dry. Okay, any pixel. So now in here we find out this type of yellow color, this type of place there was no water in the dry season. This type of place there is no water in the dry season. This type of place, this type of place, this type of place, there is no water. But in the dry season there is no water, but rainy season or wet season we find out the water. And how I can find out these things? We have just simply apply the threshold value 0.6. How I can get the value? This value give me from this threshold value, basically this type of histogram or frequency. In this case I check here, this is the highest 0.6 we find out for that dry season, 0.6 for the dry season, and for the rainy season we find out that highest 0.9. So now 0.6 greater than 0.6, all of those including indicating about that rainy season water. Okay, so these things, this concept. So for this, just compare these two graph when you work for the before flood, after flood, suppose summer season, rainy season, anything, just compare these from two chart, and from here you can easily get that threshold value, and just use this threshold value, and then we can easily get it, this type of water. And this water we can only find in the rainy season. There is no water, this type of water is not available in dry season or summer season. This is not available. Okay, so I hope you can get the idea how we can easily apply the threshold technique. So now I want to calculate how much area, suppose this type of yellow pixel, how much area. We calculate the total area of water for this rainy season or this type of water we calculate. Okay, so okay, so for calculating this type of things we have to use a function, this function called the ee.image.pixel area. So if I just search here this function ee.image.pixel area, you can see this function we have to use in here. So this function always we are use when you calculate the area, okay, pixel area, and it show the result in square meter. When you use the function we find out the default result as a square meter, but further we also convert the unit as a square kilometer or hectare, different types of unit you can convert. So let's go try to calculate this area, how much rainy season water we find out in here. So for calculating this area, just okay, so let's go try to show them one by one. So one is the chart method for calculating the area, another is that normally, okay, random. So let's go try to check the random, how we can easily make the chart calculate the area, mainly statistical value only. So for that, just take a variable, suppose area, and I want to calculate the area. So just call the function ee.image.pixel area, just call this function,